Hey, boys and girls, another exciting episode. This is going to be our assignment for Friday. I know a lot of you are going to get on, and it's going to show that there are 37 questions, and you're going to freak out because that seems like a lot of questions. But this is five of them, and I'll show you kind of how quickly we can go through that. Okay, so the basic idea here really, all of these questions. Again, I said, some of you are going to look at it and say, 37 questions, that's way too much. You really just have to do 7 times 1 and then count. For instance, this is just regular old 7 times 1. It's called the identity property. Whenever you multiply any number by 1, it stays the same. Okay, that same exact problem is in this next one. It's really not much harder. We still have our 7 times 1 and then that 0. So 7 times 1 is still 7. And then that 0 is just going to come over here. We just have to count, right? There is 1, 0. So 7 times 1 turn to the 7, and then the 0. And then when I go back to this next one, kind of same idea. 7 times 1 is still 7. That hasn't changed. And then I want to do that one backwards. Let me see. And then the zeros, right? These two zeros. Okay, so we had 7 times 1 stayed the 7, and then the 0 and the 0. It's just the counting of that afterwards. Okay, so again, I told you it's going to look like a lot of work, but the actual math here isn't that hard. Again, here's our 7 times 1 again. That's still 7. And then again, when we come here, and now my 0 and my 0. So that's really the same exact problem, right? That's the 1 0, and that's the other 0. So it's really just counting the zeros after one. This one just throws in the word 7 ones. That just means 7 times 1,000. So again, still just 7 times 1. And now the only difference here is now there's 1, 2, 3 zeros. So again, in my answer, I'm going to have 1, 2, 3 zeros. And then kind of the same thing happens, but backwards. Sometimes they'll give it to you this way. They'll say 8 times something equals 800. Again, we're trying to find that missing piece. How did we get from 8 to 8, the regular number part? We times it by 1. And then what else would we need to do to 8 to make it 800? And we need those two zeros. So that's kind of the same thing, but in the opposite direction. And then same thing with 8 times something equals 80. Again, how do we get from that number to that one? We would times it by 1. And then we just need one more 0. So 8 times 10 equals 80. You've been having that kind of on your Thursday math facts is 80 divided by 10. And you kind of do the same thing that way. You basically kind of chop the zeros off, and then it's 8 divided by 1 equals 8. Because again, that's kind of the same thing but backwards, because the zeros are already taken care of. Here I have kind of an imbalance. I have 1 0 over on this side, but I don't have any over here. So I kind of need that 1 0 on each side of the equal sign, of the equation. That's really what an equation is. It's kind of a balance. I have 80 on this side. I only had 8 over here. When I put that times 10 there, right, I now have 80 on both sides. It is now equal, which is why we call it an equation. Then they'll give you a section of just kind of random ones like this. Again, it will look like a lot, right? There might be like 9 or 10 questions in this particular part. Again, each individual piece, though, is not going to be that difficult. The basic idea is just 1 times 4. That's really the only math you have to do here. And then you got to do a little bit of counting, right? So 1 times 4 makes 4. And then I just need to count 1, 2, 3. All 3 of those come over to the other side. 1, 2, 3. Good. So 4 times 1 is 4, and I put the 3 zeros on the end. Same thing here. My basic math fact here is just 6 times 1. 6 times 1 makes 6, and then the 1 0. 1 0. I now have that balance that I was talking about. And then same thing here with 2 times 1, that's my math fact, is 2. And then again, then I go back and I count the zeros. It's almost like two separate things. Do just your basic math fact that's always going to have ones today, and then count the zeros. 1 and 2, 1 and 2. Now this one again is backwards. What times 3 would turn it into 3,000? What would I have to do to 3 to make it 3,000? Again, I know my multiplication, the 3 is going to stay the same, so I times that by 1, or I multiply it by 1. And then what am I missing on this side that I have on this side? Right? And that's going to be these 3 zeros. 1, 2, and 3. And then 1, 2, and 3, and my comma. See how those are now the same amount? Okay, so the number you're multiplying by 1 really doesn't change anything. I'm trying to see if this is any better with the lights on or lights off in terms of the glare. So we'll be able to kind of test that out tomorrow. Right, so we have 14 times 10. Again, it's still our basic number times 1. That still stays as 14. Right, I could have 1,472 times 10. It would still stay 1,472. And then a 0 on the end. Same thing happens here. The 14 stays the same because I multiplied by 1. Then I need my extra 0. Right, so I'll switch colors for this one. Same idea here, right? The 19 times 1. That has not changed. That's still just 19. Okay? And then I go back and I count my zeros. 1, 2, 3. See, so these two are taken care of. I took care of those two parts already. That turned to 19. What I haven't used yet is this. Again, I just have to go back and count. 1, 2, 3. I don't know why that's not working. There we go. Okay? And then I wanted to show you this one using the chart. Right, so this is the number that I am starting with. You're not going to have to do any of the charts or any of the moving the things around. I just wanted to kind of show you an example. And I have 110, that's this one, and then I have 3 1s. What would happen is I'm going to shift it based on the number of zeros. And I look at that and I count, there's 2 zeros there, right? That means all of my numbers are going to shift 2 spots to the left. This is going to go over 1, 2. That 1 is now going to be here. Should I switch colors for that? And then the 3 is also going to shift over 2 spots. It's going to come to here. Okay, so that's kind of what you would have done if we had kind of the paper pencil version of this. And then I try to look to see, well, what is my new number? How much do I now have? And you can kind of see it here, right? I know I kind of wrote that quickly. I now have 1,000. I now have 300. That's the same idea that happens when we're just doing the regular multiplication out. Right? 1 times 13. That stays 13. And then 0, 0 becomes 0 and 0. So this is kind of the example again. You're not going to have to actually do that. You just write done or just write all set or just write whatever. Okay, but this is what would have happened. Again, if I times by 10, multiply by 10, I move over 1 spot because there's 1 0. If I was to do the chart with 1,000, because there's 3 zeros, that tells me I shift over 3 spots. It would happen the opposite way. When I divide by 10, I'd shift everything 1 spot that way. When I divide by 100, I would shift everything 2 spots that way. When I divide by 1,000, I would shift everything 3 spots that way. That's part of that kind of base 10 system I've talked about, right? Because we have 10 fingers. People kind of count when you're little, right? You kind of do that. So again, when I get to 10, If I want to count to 11, I don't have an 11th finger. So it's like, okay, I have 110, and now I have 1, 1. And I'm able to kind of keep that going that way. Okay, and then these are a couple kind of the harder ones it's going to have you do towards the end. This might kind of confuse you at first, or might kind of trick you at first, so I want to kind of show you. Right? They're going to kind of just break it apart differently, and then essentially just do the same thing. So this is when there's not a 1 anymore. Like we have 3 times 4 is our regular multiplication problem here. Like before it was like 3 times 10, now it's 3 times 40. So they're showing you, again, you would break the regular numbers apart first and do 3 times 4, and then what's left is that 0. That 0 is really a 10 there. Then you do your regular multiplication, which is 3 times 4 turns to 12, and then it's 12 times 10. And just like we just did, 12 times 10 you can do. So they are going to sometimes want you just to kind of do this extra step in between. And then with 12 times 10, 12 times 1 is 12. And that's just the rule. Any number times 1 is itself. And then we need our 1, 0. So really what's confusing, or going to confuse some of you, is kind of this extra step in between. They're going to split the 3 and the 4 apart, and then the 0 becomes a 10. Again, if this was 400, it would be times 100. If this was 4,000, it would be 4,000, which I'll show you, or 1,000, which I'll show you here. And I wanted to show you this one too. This is actually the last question on there today. 5 times 4. There's something different about this one, which is why I wanted to show you this particular question. The 5 and the 4, the regular numbers, you're going to separate. That's all I did. The 5 and the 4, I split apart. They were already kind of split apart. And then the 3 zeros. Again, this is just the counting again. I need the 1, 2, 3 zeros, and then that 1. Then I'm going to actually multiply my 2 regular numbers. And here's what's going to be different about this one. Some of you might be thinking, well, I know my answer is going to have 3 zeros in it when I finish. And that is not going to work here because it's something different. Because 5 times 4, right? 5, 10, 15, 20 has a 0 in it. And then I need 3 more zeros on top of that. So just like before, this number stays because now it's 20 times 1, which is 20. And then I need the 1, 2, 3 more zeros, which is down here. 1, 2, 3 more zeros for 20,000. Okay, so those of you paying attention, that's going to be how the assignment ends. This is like number 8, something like that, and this one is question 10. All right, awesome job, and I will see you tomorrow morning.